So in this video we are going to discuss trigonometry up to transformations. Continuation. Here question is, in triangle ABC prove that sin 2a plus sin 2b minus sin 2c is equal to 4 cos a cos b sines. This is also very important problem. It was already given in the March 2025. So now here in triangle ABC given the solution, given that in triangle ABC means we know that a plus b plus c is equal to 180 degrees. So from this we can write a plus b is equal to 180 minus c, and also c can be written as 180 minus of a plus b. This is already we have seen in the problem number 1. This is problem number 2. Now taking LHS here. So LHS is given that sin 2a plus sin 2b plus here given minus sin 2c minus sin 2c. See here, the first two terms considering, it is in the form of like sin c plus sin d, sin c plus sin d, we have the formula. So that is 2 sin c plus d by 2 into cos c minus d by 2. So now applying this formula, so here clearly c is 2a, d is 2b, so which is equal to, so 2 sin, the formula is applying here, 2 sin of c is 2a plus d is 2b by 2 into cos c is 2a, d is 2b minus 2b by 2, and minus sin 2c is writing as it is. No change in that. See, if you take 2 common in the numerator, 2 gets cancelled. We get 2 sin of a plus b into, here also 2 gets cancelled in the numerator and denominator after taking the 2 common. So we get cos of a minus b minus sin 2c. See here, already we have a plus b is equal to 180 minus c. Now here already we have a plus b. Now that is replaced by, so 180 minus c, 180 minus c into cos of a minus b and minus sin 2c writing as it is. See, we know that we have the property that is sin 180 minus theta. So which is equal to, belongs to the second quadrant. In the second quadrant, sin is positive. So that's why there is no change in the trigonometric ratio. So sin 180 minus theta is sin theta. Similarly, sin 180 minus c is also sin c. When it becomes sin c, so it is completely 2 sin c, and into cos of a minus b, into cos of a minus b, and minus here sin 2c, we have the formula, so sin 2 theta, so which is equal to, we have 2 sin theta cos theta. We have 2 sin theta cos theta. So in terms of c here, writing this is 2 sin c into cos c. See, observe the first term, this is completely first term. So this is the second term. In these two terms, clearly which is common? 2 sin c is common if you observe. So taking 2 sin c common, so we get here cos of a minus b, After taking the 2 sin c common, we get here cos c. See, further I am continuing the same problem here. So this is from this step onwards continuing. So here we have 2 sin c into cos of a minus b, so minus cos c. See, if you observe here, one is in terms of a and b, so second term is in terms of c. So what I am doing is that c is also writing in terms of a and b. See here, observe carefully. Here we have 2 sin c into cos of a minus b minus cos c. See, what I am doing is here, this c is also, see here, we have c is equal to 180 minus of a plus b. Now from the same step onwards I am continuing. 2 sin c into cos of a minus b, and here minus cos. So c is also replaced by, this c is also replaced by 180 minus of a plus. C is also replaced by 180 minus of a plus. So c is replaced by 180 minus of a plus b. So now if you observe here, this is like cos 180 minus theta. See, here we have sin 180 minus theta, that is sin theta. Same like that, here also cos 180 minus theta is also belongs to the second quadrant, but in the second quadrant cos is negative, so that's why cos 180 minus theta is nothing but, so minus cos theta. So already, so this is discussed in the first problem also, in one of the before video, already I discussed it clearly. So now if you follow that, you can observe that, you can find it. So 2 sin c into cos of a minus b, minus as it is. Now cos 180 minus theta, here clearly theta is a plus b, so it becomes minus cos theta. That means here this is minus cos of theta is what here? A plus b. So that's why finally here this is minus cos of a plus b. So that's why which is equal to 2 sin c into cos of a minus b, and here minus into minus is plus. So cos of a plus b, this is it. So if you observe here clearly, we have one of the formulae, transformations formulae. So here cos of a plus a minus b or a plus b plus cos of a minus b, here a minus b plus cos of a plus b. We have the formula 2 cos a cos b, 2 cos a cos b. So that's why this cos of a minus b plus cos of a plus b is replaced by, so 2 cos a cos b. So that's why here this is 2 cos a cos b. So finally we get, so here 2 into 2 is 4 cos a into cos b into cos a into cos b into sin c. See, observe here, which is equal to RHS. See here 4 cos a cos b sin c is equal to RHS. So therefore LHS is equal to RHS. So like this we can prove this problem.